Software development used to be strictly bound by the physical limits of human typing. Every line of logic, every variable, and every configuration had to be manually keyed into a terminal by a person. Today, a single prompt can spin up hundreds of lines of functional logic in seconds. Intelligent assistants now map dependencies, execute tasks, and generate massive files with explosive speed. With this level of automation, a logical question emerges. If algorithms can write syntax faster than any team of humans, are software engineers about to be engineered out of a job? The instinct to predict mass layoffs makes sense on the surface, but looking closer at the economics of the tech industry reveals a very different reality. NVIDIA CEO Jensen Huang recently addressed this exact fear, calling the idea of AI reducing software jobs complete nonsense. This chart illustrates his math. The global workforce of software developers represents roughly $3 trillion in annual salaries. With AI assistants, those same developers are now producing nearly 3 times as much output, effectively generating $9 trillion of productive work. This productivity makes every new hire a high-yield investment. Companies are scaling their engineering departments to capture as much of this $9 trillion growth as possible. This surge is driven by what the industry calls agentic AI. Instead of simply auto-completing individual lines of text, these new tools autonomously traverse repositories, analyze context, and modify code across multiple files simultaneously. If the machines are doing the heavy lifting of writing the code, what exactly are all these new human hires being paid to do? This discrepancy is explained by the developer productivity paradox. A single programmer equipped with AI can generate code incredibly fast, but without rigorous checks, that individual speed slows down the entire engineering team. Security researchers describe modern AI as an army of juniors. It writes functional, test-passing code, but it lacks the necessary judgment to make sound architectural choices for a large, complex system. This line graph from GitClear tracks 211 million lines of code, displaying a dramatic 8-fold spike in duplicated code blocks since AI tools became mainstream. This duplication happens because of vibe coding. Developers accept AI suggestions that appear to work locally without verifying if the machine simply copy-pasted existing logic or violated the project's established conventions. The AI is not building a perfectly structured application. It is silently piling up a massive amount of invisible technical debt, leaving a chaotic structural mess that human engineers must eventually untangle. A large-scale 2026 academic study audited over 300,000 AI-authored commits across thousands of public repositories to see exactly what kind of code these assistants are merging into production. This pie chart visualizes their findings. A massive 89.3% of AI-introduced issues were code smells, like broad exception handling and unused variables, that slowly degrade maintainability. Zooming in, the 4.7% slice reveals a more immediate threat: severe vulnerabilities, like path traversal errors and unsafe database queries. Beyond structural and security flaws, there is a serious legal liability. Large language models are trained on massive public datasets, and they can easily reproduce strictly licensed or proprietary code snippets, exposing companies to hidden copyright violations. The days of paying someone to simply type out repetitive boilerplate are ending. But reviewing, securing, and legally clearing this deeply flawed AI output makes expert human oversight strictly mandatory today. This cyclical flowchart shows the AI-driven development lifecycle, a new structural framework engineered to safely manage these risks. It maps out 3 phases: inception, construction, and operations, relying entirely on human validation at the center. During the inception phase, AI drafts detailed project requirements and work plans, but the human engineering team steps in to explicitly validate that those plans match the actual business intent. In the construction phase, the AI proposes the logical architecture and the code itself. Human developers are then required to provide real-time technical boundaries and ensure the code fits the broader system design. To maintain this cycle, modern engineers are developing new tactical skills. They are establishing rigorous automated quality gates and conducting highly specialized AI-aware code reviews. Engineering teams are no longer treating AI as an autonomous replacement. They are managing it as a hyper-productive junior teammate that requires strict guidelines and constant supervision. Ironically, developers are now deploying background AI agents to continuously scan repositories and clean up the technical debt left behind by other AI code generators. The traditional perception of a programmer sitting in a dark room manually typing out syntax is obsolete. The role has evolved into that of an architectural thinker and a rigorous security reviewer. Writing raw code has become a commoditized task, yet the ability to orchestrate that code to solve complex, system-level business problems is more valuable than ever. The modern developer acts as a system architect. Machines now handle the masonry of raw code, while humans design the cities.